Let's take a look at energy. So again, I have my parallel plates hooked up to a battery. So as soon as I hook it up, I'm going to have charge start flowing out of the battery onto the plate, which will then chase charge off the other plate, which will then go into the battery. Now the first charge I put onto the plate is easy. There's not a whole lot of resistance. The plate is neutral, so it doesn't take much to force an electron onto the right-hand plate. So now the plate has a charge, so when I try to put the second one on there, it's going to be a little bit more difficult. Even though it's attracted to the positive plate over here, the negative charges will be closer, and so it's going to get harder and harder to put charges onto it. So if I want to look at how much work it takes to put a charge onto it, I know that the work integral of F dx, whatever letter you're using, let's see, so df is that way, so technically that is negative, the dot product, the force on the electron, which force we're talking about, the force from the electric force on it is going to be this direction. As it moves in that direction, the minus signs will cancel out. So the work would be F dx. Now I know that the force on the electron is just the charge times the electric field. And oh, that was not the direction I wanted to go in. Well, no, we're here. This Q is thus the charge that we're putting on it, so that is, no, actually, that is just the long way. All right, I'll make it work. I know EDX, the electric field times the change in position. Generally are assuming that the electric field throughout the wire, it's kind of like a waveguide, the electric field throughout the wire is relatively constant. So this is just dV, so this is Q dV. I know that the charge here is related to the capacitance. Then, sorry, let me just take a look here. That is the charge I'm putting on there. All right, I'm going to start over. Take two. I know the change in potential energy is equal to Q times the change in the electric potential. Or if we do it infinitesimal, since this is going to be varying, equals Q dV.
integrate both sides. The left side, we're gonna go from 0 to whatever the potential energy formula is. On the right-hand side, we're gonna go from 0 to however much charge we're putting on the plate. I know that Q over delta V is equal to C. Wow. I'm heading all sorts of bad directions here.
All right, why don't we take 5? Let me figure out where my brain is gapping.